Hi, today in Math 0955 we're going to talk about adding and subtracting polynomials, and we begin with identifying how many terms the polynomial has and then the degree of the polynomial. So in problem 1 we have 9x minus 7. There are 2 terms. The 9x is one of the terms, the negative 7 is a second term, so we call that a binomial. That prefix bi, like bicycle, there's 2 of them. The other prefixes you see on the terms to the right, mono for 1 and tri for 3. So is there a tricycle? Is there a monocycle? Anyways, 2 terms, binomial, 1 term monomial, 3 terms trinomial. For the degree of the polynomial, what you do is look at the variable, and then the degree is the exponent on the variable. So remember exponents. So if we have something like 3 cubed, that's equal to 3 times 3 times 3. That number in the sky there, and the 3, let's make it more obvious. So this 3 to the 4th. This number in the sky above the 3, the number 4, is called the exponent, and it's a shorthand way of doing repeated multiplication. So if you have 3 to the 4th, that just means to multiply 3 by itself 4 times. Okay, so in our particular instance, we have a variable raised to some power. So I have an x, and there's no power there, but we just presume that means 1. Okay, so there's a power of 1 if you don't see some power there, which is just x. So if I have x squared, that just means multiply x by itself twice. If you have x cubed, it means multiply x by itself 3 times. But the point here is, for the degree, you look at the exponent of the variable, and in this case it's just 1, so the degree is 1. Okay, so it's a binomial, and the degree is 1. Okay. Number 2, the same kind of form. It's a binomial because there's 2 terms. There's the x to the 4th, and then there's the 3x. So again, binomial there. And then for the exponent, what you have 2 variable terms there, right? So you have this exponent of 4, and on the other one you don't see it, so you just presume it's an exponent of 1. So for the degree, you take the highest exponent. Okay, so in this case, it's not 1, it's 4. You want the biggest exponent. Okay, so it's a binomial, and the degree is 4. Okay. Problem 3, this is a monomial. There's just one thing there, and then the degree is 2. Okay, so it's a binomial. Sorry, it's a monomial, and then the degree is 2. This one's a little weird, number 4, because it doesn't seem to have a variable attached to it. It's a monomial, first off. Let me fix number 3 there. That is a monomial. I was very insistent on writing a binomial there. So there's only 1 term. And so the same thing for here, number 4, there's only 1 term, so it's a binomial. The question then is, what the heck is the degree? Because you don't really see a variable there. Well, if you remember, we have this rule for 0 exponents, right? So 2 to the 0 is 1. So x to the 0 must be 1 unless x is 0. So if you don't see the variable there, you kind of pretend it's really there, but it's x to the 0. So the degree is 0. We would never write x to the 0. Technically, it's not correct. So we just leave it as is and say, if you don't see the variable, say the degree is 0. All right, so number 5, there's 3 things there. X squared, then minus the 6x, and then plus 9, so it's a trinomial. And then the degree is 2. The highest exponent is 2. One thing to note about this trinomial is that the degrees of the particular terms are in descending order. So I have in the first term x squared, and the second term is x to the first power, and then the third term is x to the 0 power. So it goes 2, 1, 0. That's called a descending degree, okay? Which is the form we usually want. We want the highest exponent first and then everything else. So this is a trinomial, and the degree is 2. Okay, so let's just look at this one, number 6. It's a trinomial. There's 3 things there. And then the highest exponent looks like it's 7. This one's a little tricky. It's definitely a binomial because there's 2 terms. The problem is it's not written in descending order. In other words, they haven't put the highest degree terms first, right? So the highest degree term is actually the second term, which has degree 7, so that will be the degree of the polynomial. This is a monomial, degree is 26. Okay. At question 9, we start adding polynomials, and then the key to it is to combine like terms. Okay, so problem 9 is our first introduction. You have the polynomial 5x plus 7 plus the polynomial negative 15x plus 4. Okay. The parentheses aren't necessary here. They just indicate that here's one polynomial, here's the second polynomial. Okay. So as soon as you want, you can drop the parentheses and then start adding like terms. So it would be plus minus 15, which is the same as minus 15. And then add like terms, so you have a 5x and a negative 15x gives you negative 10x's. And then 7 plus 4 gives you 11. Type that in. Okay, so it's very simple, so long as you can kind of identify the like terms. Let's try number 11. As soon as I write it, I'm going to get rid of those parentheses. I don't really need them. Okay. And then I'll combine the like terms. So first you add the x squared terms together. So 6 plus 3 is 9x squares. And then I'm going to add the x terms together. So I have negative 3x's plus another negative x gives me negative 4x's. And that would do it. 9x. I use the caret key for the exponents and then the arrow key to get out of the exponent. So the caret key is right above the number 6 on your keyboard. Here I am adding another set of trinomials this time. So I'll get rid of those parentheses already. 8y cubed plus 3y minus 12 plus 12y squared minus 2y plus 1. Okay. So first off, the 8y cubed doesn't really have a complementary term to add it to, right? So it's just the 8y cubed. There's nothing I can do with it, so I just copy it down. I want to go in descending order, so the next terms I'll look for are the y squared terms. Okay, so there's just the 12y squared, so I'll go plus 12y squared. And then I'll look for the y terms, so there's 3y minus 2y, which is minus 1y. And then finally the constant terms, negative 12 plus 1 is negative 11. then you just zip over here, 8y cubed plus 12y squared minus y minus 11. Right 2. No, it's plus y, sorry. 3y's minus 2y's is 1 plus 1y. More of the same, just adding like terms together. Higher exponents. Here's one with some fractions. Let's go ahead and do that one, number 17. So 4x cubed minus x squared minus x minus 3/4 plus x cubed plus x squared plus x plus 7/4. Okay, so the x cubed terms, there's 4 of them there, there's another one there, 5x cubes. Looks like the x squares terms cancel out, and so do the x terms, those cancel out. And then negative 3/4 plus 7/4 is plus 4/4, which is just 1. So it's fairly painless. Cubed plus 1. Okay. Oh, more fractions, but that's no big deal. 1/3 x to the 4th plus, and of course I don't need the parentheses, let's get rid of that. 1/3 x to the 4th plus 1/7 x cubed plus 1/8 x squared plus 7 plus negative 2/3 x to the 4th plus 4/7 x cubed minus 1/4 x squared minus 7. And of course, if you want, you can write that minus 2x to the 4th instead of parentheses plus parentheses negative 2/3 x to the 4th. Anyways, combine the x to the 4th together first. So I got 1/3 minus 2/3 gives me minus 1/3 x 4th. 1/7 x cubed plus 4/7 x cubed plus 5/7 x cubed. 1/8 x to the 4th, 1/4 x to the 4th, so I'm going to find a common denominator. That will be 2/8 minus 2/8 x to the 2nd power. So 1/8 minus 2/8 is minus 1/8 x to the 2nd. And then the 7 minus 7 is 0. So 1/3 is 2/4 5/7 x 3rd minus 1/8 x squared. And that should do it. Some decimals there. Vertical format for adding polynomials. So for these, it's kind of like the addition method and the solving systems of equations. You're just going to add column-wise. There's another one. We could try the fraction one. Okay, so number 22, I have 1/8 x to the 4th minus 2/3 x cubed minus 2, and then plus this minus 1/4 x to the 4th plus 1/5 x cubed plus 1.4. I'm just going to add column-wise. So in the first two terms, I need a common denominator, so I multiply top and bottom by 2 there. And that's going to be a negative 2/8. So it'll be 1/8 plus negative 2/8 is negative 1/8 x to the 4th. And the second term, I'm going to need a 5 in the top and bottom there on the first guy, and then a 3 in the top and bottom there on the second guy. So this top guy is going to end up being 10/15, and the bottom guy is going to be 3/15. Adding those together, it'll be plus, so just add the numerators. 10 plus 3 is 13/15 x cubed. And then minus 0.6. And that should do it for us. Negative 1/8 x to the 4th plus 13/15 x cubed minus 0.6. What row? What did I do? Oh, that second guy, this is a negative 10/5. That may have something to do with it. So negative 10/5 plus 3/5 is going to be negative 7/5. So that's one mistake. I was going to prepare myself. Usually, well, not usually, but sometimes I do multiple mistakes. If you don't acknowledge that up front, you'll get really frustrated because you mistake. It's like, okay, I make multiple mistakes sometimes. Anyways, there's that. This one's a little odd because it's you're missing terms when you add them, but it's no big deal. You just okay. So I have 2x cubed minus 3x squared plus 4x minus 8, and then minus 4x cubed. There's no x squared term. So what they try to do is align the like terms. Okay, so 2x cubed minus 4x cubed is minus 2x cubed. And then you got negative 3x squared and then 0x squares. There's no x squares in that position, so it's just bring down the negative 3x squared. 4x minus 2x is plus 2x. And then negative 8 plus 7 is negative 1. So I got negative 2x cubed minus 3x squared plus 2x minus 1. And, oh, put minus there. Okay, great. So more of the same stuff. Here's one. They're just getting carried away at this point with the vertical addition. This is no different than what you did with arithmetic, and maybe you had to add 3 numbers together. Sometimes it's nice to put it in this form. It makes the addition a little bit quicker if you can see the like terms lined up. It's not something I do very much though. Negative 12x squared plus 4x squared is negative 8x squared. And then you got negative 6 plus 12 is 6x plus 5x is 11x. And then 6 plus 4 is 10 minus 2 is 8. I got a capital X on there. You almost got me. Hit the cap lock. Another one, vertical format, but with decimals. Okay, so finally now we're on to adding polynomials. So subtracting polynomials. For adding polynomials, you combine the like terms. That's pretty much it. You can drop the parentheses and combine like terms. For subtracting polynomials, what you have to do first is distribute the negative. I'll show you what I mean there in a sec. So you can't just drop the parentheses at the beginning. You can't play that game. But after you distribute, then you can drop the parentheses and combine like terms. Okay. So the only real difference is there's this additional step where you have to distribute a negative. Okay, so for instance, number 28, we have x minus 7 minus 6x plus 4. It should be in parentheses. So how does this work? Well, you're thinking of that minus sign as a plus negative 1. Okay? And then you're just going to distribute this negative 1 to each of these terms. And at that point, you could drop the parentheses. So it'd be x minus 7. Negative 1 times 6x is minus 6x. Negative 1 times 4 is minus 4. And once you get into that form, you can combine like terms. So x minus 6x is minus 5x. Then negative 7 minus 4 is negative 11. So 9 minus 5x minus 11. Okay. So you just have one additional step. Let's skip that one and try the next. Okay, so problem 31. We have x squared minus 9x minus 9 minus x squared minus 6x minus 3. So you're distributing the negative. Another way of thinking of distributing the negative, which you may or may not like, is called zapping. So what you do is right at that negative, you go zap, 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 zap. And then your polynomials are x squared minus 9x minus 9 plus negative 8x squared. That would be minus 8x squared plus 6x plus 3. It's just what you're doing there is just changing the sign on all the terms, which is what the distribution of the negative does. Okay, so anyways, I get x squared minus 8x is negative 7x squared. Negative 9x plus 6x is minus 3x. And then negative 9 plus 3 is negative 6. Okay. So my teacher used to call that zapping. If you want to do that kind of method, by all means. This is Dispenza. Let's do like every other one. Okay, so 33, I have 3y squared plus 9y squared minus y minus 4 minus y squared minus 7y plus 10. And then we could zap this guy, plus, minus, minus. That would be 3y squared plus 9y squared minus y minus 4 minus y squared plus 7y minus 10. So combining the y squares first, we'll have 2 of those. Oops, oh, this one's a y cubed, sorry. So I have to redo that. Y cubed. And then this will be wrong. Okay, so there's just the one y cubed term. So you have 3y cubed, and then there's the 9y squared minus 1y squared is 8y squares. Then there's the minus y plus 7y's, that would be plus 6y. Minus 4 minus 10 is minus 14. So 3y cubed minus 8y squared, and I did a double negative, plus 6y, and then minus 14. Okay, and there may be multiple mistakes. So let's see what I did. This plus minus 3y cubed plus 9y squared minus y minus 4 plus y squared plus minus 10. Okay, so the 3y cubes are good. Oh, it's positive 8y. So there's one mistake. And then how about the other guys? The other guys look good. Some weird variables. You get n's in there, that's no big deal. So n instead of x. All right, sure. Let's try 36. So we have 8x to the 4th plus 3x squared plus 2x minus negative 14x to the 4th minus 8x squared minus x. So zap it, zap, zap. And then we get 8x to the 4th plus 3x squared plus 2x plus 14x to the 4th plus 8x squared plus x. And you don't have to do the zapping if you don't want to. 8 plus 14 is going to give me 10, 11, 12, 22 x to the fourth. And 3 plus 8 is plus 11 x squared. And then 2 plus 1 is plus 3x. X to the fourth. 11x plus 3. X. No, the middle one should be x squared. Squared. Fantastic. Oh, we get some fractions. That'll be fun. Let's try 37. So we have 1/8 x cubed minus 1/6x minus 1/6 minus negative 5/8 x cubed plus 1/5 x minus 1/6. That'll be 1/8 x cubed minus 1/6 x minus 1/6, and then distributing the negative, negative 5/8 x cubed will be plus 5/8 x cubed, and then negative times positive 1/5 is minus 1/5 x, and then negative negative again, positive 1/6. And then 1/8 plus 5/8 is 6/8. And of course, I'm going to have to simplify that, x cubed. The second term, I'm going to need some common denominators. So multiply top and bottom of this guy by 5, this guy by 6. That'll give me negative 5/30, and the other one will be negative 6/30. So that'll give me negative 11/30 x. And then minus 1/6 plus 1/6, that will just be 0. And then simplifying, so that would be 3/4 x cubed minus 11/30 x. 3/4 x cubed minus 11/30 x. Okay, and now they're going to go on with this vertical orientation, which, like I said, I don't really do this very much. There's some process called long division where you'll see this part again, so we definitely want to make sure you know how to do this. Addition, maybe not so much, but subtraction, yeah, that's going to come up again, so we want to get this down. Okay, so to pull this off, it's going to be 4x, and then if you distribute, it'll be minus 2x, so it'll be, you could rewrite it if you wanted to. It's better just to kind of try it in your head, though. Whoops, I don't want that line there. So if you distributed the negative 2x, it'd be 4x plus 2, and then negative 2x plus 3. Okay, and then you add column-wise. So 4x minus 2x is 2x, and then 2 plus 3 is 5. But you kind of want to do it all in your head. So it'd be 4x, and then minus 2x is 2x, and then 2 minus negative 3 is plus 5, plus 2 plus 3 is 5. 2x plus 5. I guess in the beginning, if you got to write it out, you got to write it out. But ultimately, we want to make it so you can kind of do these in your head. Let's try number 40. 6x squared minus 4x plus 7, and then minus 12x squared plus 7x minus 5. Okay. So if you were to distribute, it'd be 6x squared minus 4x plus 7, and then distributing the negative, negative 12x squared, oops, I hit the button, minus 7x plus 5, and that would be minus 6x squared, 7, 8, 9, 10, 11x, and then plus 12. And so the difference, negative 6x squared minus 11x plus 12. More of the same. Just have to distribute to all the terms. Let's try this one out. This is one of those ones where it's aligned a little bit funny. It's problem 43. Okay, so 4x to the fourth plus 2x cubed minus 8x squared minus parentheses, and a little space because they don't have a corresponding x to the fourth term in the second polynomial. And then it's minus x cubed minus x squared plus x minus 8. Okay. So if you want to just do it in sort of in country, so to speak, you get the 4x to the fourth minus nothing, so 4x to the fourth, then 2x cubed minus negative x cubed, so that would be 2x cubed plus x cubed is plus 3x cubed, and then negative 8x squared minus negative x squared, so that would be plus x squared, so that would be ending up negative 7x squared, and then nothing minus x is minus x, and then 0 minus negative 8 is plus 8. So 4x to the fourth plus 3x to the third minus 7x to the second minus x plus 8. I have a feeling that's not going to be right, but oh yeah, I got it. All right, so one with decimals, and I'll probably have some fraction problems. Oh, so these ones are a little bit more work. So we have 3 polynomials to worry about as opposed to just 2. But you just take 2 at a time, right? You do kind of order of operations. So you do the inside of the brackets first, where we have 5x squared plus 5x plus 2 minus negative 2x squared plus 9x minus 2, and then minus x squared plus 8x plus 4. Okay, so I do the 2 polynomials in the bracket first. So I'll have 5x squared plus 5x plus 2, and then I distribute this negative. So that will be plus 2x squared minus 9x plus 2. And then minus this other guy, x squared plus 8x plus 4. I'm going to combine some like terms here. So 5, 6, 7x squared. And then 5 minus 9 is minus 4x. And 2 plus 2 is plus 4. And I'm going to distribute the negative on that guy. So minus x squared minus 8x minus 4. And then combine like terms again. So 7x squared minus 1x squared is 6x squared. Negative 4x minus 8x minus 12x. And then 4 minus 4 is 0, so you just get 2 terms for a binomial with degree 2 of x. Okay, this one's kind of the story problem, literal translation. Subtract the cubic from the sum of 7x cubed plus x squared and negative x cubed minus 9x minus 9. So you're taking that sum and subtracting away x cubed minus, make sure that's in parentheses because you're subtracting the entire polynomial, not just part of it. So you're going to have to distribute that negative. Then we'll rewrite it here. Plus negative x cubed is just minus x cubed. And then if you want, you can go ahead and distribute. And then combine like terms. So 7x cubed minus x cubed is 6x cubed. X squared plus 4x squared is plus 5x squared. And then there's this, oh, there's another x cubed? Ah, crud. So anyways, minus x cubed. And then minus 9x. And then minus 10, so I have to combine still the x cubed parts. 6 minus 1 is 5x cubes, and then plus 5x squared, and then minus 9x minus 10. So the result is 5x cubed plus 5x squared minus 9x minus 10. What a mess. All right, there it is. Oh, that's incorrect. Well, how many mistakes did I do this time? There should be a minus there, so there's one mistake. Oh, just one mistake. That's awesome. Okay, 47 is another story problem. So first they give you a model S, which represents racial bias in an age group. Okay, so part A, they give you this model S, which is 0.2 x cubed minus 1.5 x squared plus 3.4 x plus 22 plus 0.1 x cubed minus 1.3 x squared plus, I'm running out of room, 3.3 x plus 9. Okay, so they give you this model. It's degree 3. And this polynomial model, S represents the score on a test of racial bias for age group X. Simplify the model. Okay, so that's simple enough. You just add the like terms together. We could drop the parentheses if that helps. It's just addition of polynomials, so you don't have to distribute or anything. And then we can combine like terms, so we have 0.3 x cubes, and then the x squares. Let's say there's negative 2.8 of those, and then the x terms, 6.7 of those, and then the constant terms. Looks like there's 31 of those. So S is 0.3 x cubed minus 2.8 x squared plus 6.7 x plus 31, as they would say in French. I think that's how they say it in French. Anyways, let's check it. Yay. And now they want you to use this model in order to make a prediction about age group, the age group from 45 to 54, okay, the racial bias in that age group. So part B, find S for age group. And you have to kind of look at the graph over here for this. If you go over to age group 5, it's the purple bar. That's the 45 to 54 age range they're asking for. So in the question part B, it says use the simplified form of the model to find the score on the test of racial bias for the group in the 45 to 54 age range. So if I go to the chart, the age range 45 to 54, that's group 5. Okay. So for x, you're going to let x equal 5. Okay. So in that case, you'll have 0.3 times 5 cubed. 5 cubed is 125, believe it or not, minus 2.8 times 5 squared is 25, plus 6.7 times 5 plus 31. And I need some sort of calculator mechanism. 0.3 times 125 minus 2.8 times 25 plus 6.7 times 5 plus 31, and it looks like it's 32. Oh, they want you to compare that to the actual value. So if you look at the chart for group 5, it's 32 as well. So they are the same. And then this one's kind of weird. They want you to show in the rectangular coordinate system. Oh no, shown in the rectangular coordinate system is the graph of the polynomial model. So they graph this S function in the XY plane and it has this weird kind of shape to it. And it describes the scores of the test of racial bias by age group. Identify part B as a point on the graph. So they just want you to type in the information as an ordered pair. And basically what you had done was plugged 5 in for x. So you'll have an x comma s coordinate, so to speak. So when you plug in 5, you get out 32. So the ordered pair that you should see on the graph is 5, 32. So if you go to 5 and then go up to here, that should be 32. So I'll put it in as an ordered pair, 5, comma 32, and that should do it. Check. Okay. Okay. So right. It's so these are hopefully pretty simple. For the you know, first you're identifying, is it monomial, so does it have one term? Is it binomial, 2 terms? Trinomial, 3 terms? And then the degree is the highest exponent you see in the polynomial. To add polynomials, you just basically drop the parentheses and combine the like terms. To subtract the polynomials, you're basically distributing the negative and then combining like terms. And then there's the vertical format where you can, in the problem itself, just distribute the negative and kind of remember, okay, it's 4x minus 2x, and then it's 2 minus negative 3, which is 2 plus 3, which is 5. Or you can rewrite the thing in the more readable form that I have on the right. And then they have some, okay, so I think we're good here. And as usual, thank you for watching, and I'll see you next time.